Welcome to Debate at Lund, here at Café Atten in Lund University. This is part of the celebrations for the 350th anniversary of Lund University, and during this week there are a lot of events, talks, discussions, conferences, symposia about the brain, about neuroscience. Neuroscience is undoubtedly one of the most active areas of modern science. Tens of thousands of researchers around the world studying the nervous system, trying to understand how it works. Now, a lot of that experimental work is on simpler animals, even on worms and fish and fruit flies and mice, particularly mice. But the ultimate question for most people, of course, is how does your brain work? How do you operate in the world? How do you understand what's going on around you? How do you see things, feel things, decide what to do? In other words, what's the relationship between what you would call your mind, yourself, and this thing inside your head? So that's what our discussion, our debate is about this evening. So we have three very eminent contributors who are very well qualified to talk about these problems. First of all, Bob Knight. Bob Knight is Professor of Psychology and Neuroscience at the University of California in Berkeley. He works on attention, on memory, on the effects of damage to the brain. Then we have Annika Wallin, who's from here in Lund, who's a cognitive psychologist. She's interested in how the brain, how the mind operates in the real world, how we solve problems, how we make decisions. And then finally, Germund Hesslow, who is also in Lund, who started, he told me, as a philosopher, but is now a neuroscientist, professor of associative learning, and he's particularly interested in exactly that, in how we learn things, how the brain enables us to learn. So I'd like to start by asking the three members of the panel just to state very briefly their view on this question. Can neuroscience explain the mind? Bob?
Yes.
No, not that brief, Bob.
My view is that the mind is not in the cloud, it's not in a church, it's between your ears. So in the end, it's all explainable by understanding the nervous system. So I would have a pretty strong view that that is the future.
You don't want to say anything more. Don't you see that there are limitations, there are problems, there are challenges to that view?
Well, there are many challenges. I mean, we're probably somewhere around 1910 in physics. We have lots of data and maybe not the great theories yet. And then Einstein comes along and things start clarifying. I think neuroscience is a baby field. We think it's mature and it makes it on the front page of papers, but I don't think it's advanced yet to where it will be. I think the other thing for me is, in terms of the mind, and I'm sure my colleagues will talk about this in more detail, many of the things that influence our behavior we don't realize are happening. And I'll make a real quick example. And I'm sorry because I hate to mention the word Trump. But since I'm from the United States, I'm going to give you a Trump example. You're a patient, and there's a patient like this in Lund, there's a patient like this all over the place. They've had damage to the right hemisphere, typically the right temporal parietal area, and the left side of the world doesn't exist. So the patient's sitting here, they had damage, they're looking at those lights, and you say to the person, you say, what do you see? And they see everybody on this side of the room, and they report nobody on that side of the room. It's not a visual problem. It's a problem with conscious allocation of attention. Now you do this simple experiment. You show them, you flash them two pictures. They're looking here. In one picture, there's all the people in this room, and they look very happy. They're at an interesting meeting. That's one picture. The second picture you flash them is all the people in this room, except half of the people on this side of the room are carrying Trump signs. And you say, is there any difference between the two pictures? The picture one and picture two. And the patient says, no, there's no difference. They look exactly the same because they consciously don't see the left half of the room. But now you say, which of the group do you want to go out to later and party? And everybody, well, I shouldn't say that. I don't know your political preferences. Everybody says the first one, the room without the people with the Trump sign. You didn't see it, but it influenced your behavior. So this is one of the cardinal features of human behavior. We think we're sentient beings and everything is rational. It's actually not true.
Well, what you're getting to, and it's the heart of the issue, of course, is consciousness, is subjective feeling about the world and whether it matters. We'll get to that later on. Let's go to Annika. How do you answer the question, Annika? Can neuroscience explain the human mind?
Probably not. Well, at least not on its own, and probably not all of it, but certainly parts. And maybe the parts that we can't explain aren't particularly important either to actually understand scientifically.
The importance, in what respect?
Well, I mean, so we were talking about consciousness. I'm not completely convinced that we can explain everything about consciousness using science. I'm also not sure that it's a really interesting question to ask scientifically.
Well, that would be, I mean, philosophically very important. If you think that the things that you can't explain are not interesting, not important, then that makes it a lot easier.
Yes, of course.
Okay. Germund, what's your answer to the question?
Definitely yes. I'd like to use an analogy here that it's not my idea. I think it comes from Daniel Dennett, who said that the mind is in many ways similar to the concept of life. If you go back 100 years, biologists and philosophers used to discuss what the nature of life was, what's the difference between living and dead or inanimate matter. And nowadays, no one has come up with sort of the final answer, but no one is asking the question anymore, because the question has been sort of dissolved into a number of more specific questions, like how does a cell reproduce, how does it maintain equilibrium, how does it maintain pH and different concentrations of ions and so on. And I think it's very similar with the mind. It's not a concept that is really good for science. Yeah. It will eventually dissolve into a number of more specific questions. And I think that some of these questions can be answered already now. If you take like a classic philosophical problem like the nature of mental objects, this was a problem for classical philosophers because you can imagine, let's say, a house, your dream house. It's very large, but it doesn't take a lot of space in your brain. And you can imagine a house that's twice as big, and it won't take up twice as much space. And it simply lacks a lot of physical properties. But obviously, it exists. So what is it? If it's not a physical object, then it must be something else, like a mental object. So what's the nature of the mental object? Well, intuitively, you might say that if I can see this dream house, there must be something there to be seen. But actually, it doesn't have to be. If you can activate your visual cortex in the same way that it was activated when you were actually looking at a house, you would, in effect, see a house, even though there's nothing there to be seen. It's sort of like looking in a mirror or even looking at a television screen. You see people and you see houses, you see objects. And what are they? They don't take up a lot of space. They don't have physical properties. So in what sense do they exist? Well, it's not a problem if you understand how the image is being generated from the sort of the USB memory or the digitized signal coming through the antenna or something like that. So the problem, or the puzzle of mental objects is already solved. We can answer it. And I would say that it's the same with many other problems about the mind, that we have sort of contours of an explanation. For many of them, we don't have an explanation right now, but I see no reason why we won't have them soon or eventually. Okay,
so we have two optimists and one moderate pessimist, but a pessimist who thinks that your concerns are not worth worrying about that much, are likely not to be that important. Well, that's an encouraging start. I think you've already started, Germund, to begin to answer my second question, which is, what is the mind? Before we start this discussion, we need to have some ground rules for what it is we're trying to discuss. We all think that we understand what a mind is. We have it. We use the terminology of the mind, self-awareness, decisions, volition, choosing, acting, agency. We have all this rich vocabulary which relates to this concept of having a mind. But are we really certain what the mind is? Bob, to you, what is the mind?
I don't know. I really
we're not
know.
so certain.
I think there's a lot. We kind of put together what we think is our conscious world. We kind of decide what our mind is. But as I mentioned before, there's many things that are influencing you that you're completely unaware of and have profound effects on your behavior. So I think if you think the mind is free will and making decisions, I don't think that's how people really operate. I think it's, I think in the U.S. there's like juries, okay? Juries make decisions about guilt or innocence. And there's 12 people, and they have to come to a conclusion. And you can see in the juries are often dominated by one or two people. And you could be going towards a vote in the jury, they're taking polls, it's 10-2 for acquittal. And then they're getting closer to the weekend, and two of the juries have some sports tournaments for their kids. They got to get this over. They take over, everybody's opinion changes. And it goes from 10-2 for acquittal to 12-0 for acquittal. 12-0 for guilty. So how do you really explain that? There's just so much variance in what we consider our organized, clearly defined decision making.
Yeah. So you're kind of saying that mind, in a sense, doesn't matter. We don't really understand what it is. It's a funny sort of word. Let's just get on with the job of defining the brain and how it works.
I think so. That'll give us more
but the
insight.
problem is that people live in a world of minds. And your example of the legal system is a very good one. If we suddenly decided, well, let's get rid of this concept of mind and volition and free will and responsibility, it makes no sense. The legal system would collapse. I mean, politics would collapse. Contractual relationships would collapse. I mean, most of society is built on the view that everyone understands that everyone else is an agent, a free agent. We all operate understanding that. So can you imagine a world where everybody recognizes there aren't really any minds?
I would hope so, because I think we'd probably interact better. I think what really happens is that group decisions, political decisions are probabilistic. We think they're definitive, and we think everything we do is definitive, and I don't think that's actually the sum of or the workings of our brain.
Annika, what do you think?
I think I would agree, actually.
Are we going to have any disagreement this evening?
Let's see. I think that often when we talk about it, it sounds like everybody knows what they're talking about. It's like, oh, yes, I have a mind, everybody else has a mind, we talk to each other, and I can figure out how other people work and so on. I would say, honestly, most of the time, I don't have a clue. I don't know what I'm doing or what anyone else is doing, but I seem to get by quite fine anyway. So I think it's sometimes it's also just labels that we put on things. We have this idea that we know how we make decisions, how society works, in a sort of folk psychological way, but basically I think it's probably not true that we do.
Okay, so one of the dominant concepts in cognitive, so particularly developmental cognitive science in the last 20, 30 years has been the concept of theory of mind. The idea that at some point in a human being's development, maybe 3 years, 4 years of age, this little baby suddenly realizes that these other people around it have views and understanding of the world which might be different from theirs, depending on their knowledge of what's happened. And I think most people would say that's extremely valuable to all of us. We look around the room and we kind of judge, well, what's that person likely to think of the present situation? What do they know about it? Therefore, how are they going to behave? So we're performing a kind of complex analysis, trying to predict human behavior on the basis of our understanding, even if it's unconscious, our understanding about the nature of other minds. Isn't that useful?
It could be. Thinking of how I operate myself, I don't know how useful it is for me personally, but that could be because I really suck at understanding other people.
I thought, yes,
Yeah.
it might be politically incorrect, but I thought women were supposed to be better at that. Yeah. Germund, what do you think? Theory of mind.
I don't like the concept, but I couldn't really tell you why I don't like it. In my view, you're wrong when you say that everybody understands what they mean when they use words like mind and consciousness and so on. I think that people are using these terms in many, many different ways. I can talk about being conscious as opposed to being unconscious, and then it means just being awake. But it could mean many different things. And if you talk about the mind, well, what I have in mind when I tell you this or that, or when I'm talking about this, is very, very different from speaking about the mind sort of in general. And when I talked about the dissolution of the concept of mind and consciousness and so on, I really meant it. I think that these concepts are very, very primitive and outmoded, and I think that science will replace them with a different set of concepts.
Oh, okay, so we've all known since Copernicus that the Earth goes around the sun, but it doesn't stop you seeing the sunrise. I mean, and that's our vocabulary is all in a kind of Earth-centered view of the universe. So it doesn't change necessarily our basic perception of the world. So would more and more knowledge of the brain really change our perception of each other and of ourselves?
I think so. Especially when you're talking about free will and stuff like that. I think that our views on personal responsibility, for instance, will change when we gain a better understanding of biochemical and neurological processes that drive our behavior. So if you, it's taken humanity a long time to understand that, for instance, that animals don't have the same kind of motivation that humans do. I mean, if you go to medieval times, they could have a trial with the cat, for instance. It took a long time to understand that people with mental disorders were not either ruled by the devil or just being obnoxious, generally obnoxious. We have gained sort of gradual understanding of people who have, let's say, brain damage, and I think that people are gradually coming to realize that some of us are born with more, let's say, aggressive tendencies or tendencies to react, respond in ways that may be socially unacceptable. And I think that this will change laws, and I think it will change how the courts look on personal responsibility, legal liability, and so on. I think that our views of human nature will change quite dramatically by neuroscience eventually.
Okay. Let's turn to what might...
Could I just,
Bob,
because I disagree, so
yeah,
you want us to disagree, that's what you said. I actually think theory of mind is extremely important because it allows you to read other people and make inferences about what's going on in the world. And if you asked, I'll go back to neurological patients because I understand, well, I know that field very well. If you asked a family member, would it be more desirable to have a family member who was paralyzed in the right arm to interact with, or a family member who was walking and talking perfectly, but had damaged their orbital frontal cortex and couldn't read the people around them well anymore? Every time they would pick, they'd rather the paralyzed arm than the loss of the ability to read people. I also think that we need to remember we are not a computer. We are not a decimal point precision machine. Humans are probabilistic, and we make errors all the time. And in fact, we've evolutionarily developed an error detection system. So if they say, Bob, reach to that cup, reach to that cup, reach to that cup, and then I one time go that way, the brain in a tenth of a second says, oops, you're making a mistake. And that allows us to not have to use all the energy to be precision. So I think we're built innately to make mistakes and make probabilistic decisions.
But reading people and attributing them with beliefs and desires isn't completely the same thing, is it?
No, and that could be wrong too. Your ability to, as Germund said, you could have there are people who can't read people.
Yeah.
Right. So, but I do think the more we understand about the nature of human behavior, the more we will appreciate other people and understand them. That's just my view.
Yeah, but it's. I mean, as you say, Annika, not being able to exercise what we call theory of mind produces problems. I mean, we have a category of mental disorders, the autism spectrum disorder, which are largely characterized by deficiencies in being able to understand the feelings and intentions of other people. So at that level,
I mean, that I completely agree with, yes.
Well enough. I mean, we were talking at dinner before the meeting and about whether, I mean, how valuable our attribution of importance to the mind is, because if you ask a normal person whether they'd rather lose an arm or a leg or lose their ability to know about themselves, they'd be really shocked at the notion of not having any conscious experience. If you said, no, it's all right, you will behave in exactly the same way. In all circumstances, you'll make the same decisions, you'll drive your car just as well, you'll do your job, you'll fall in love, all of these things, but you just won't know about it. People would still be just as horrified. They'd say, take the arm or take the leg, don't take my consciousness. So why? I mean, this is perhaps an evolutionary question. Why do we attribute such importance to subjective states, to consciousness?
I think it's because that thought experiment doesn't really work. I think that people will not really accept the premises of that argument. They won't believe that not being conscious would generate the same behavior, etc., etc., etc. I think they realize that, and our consciousness is important for trying out various courses of action, for understanding other people in order to predict them, in order to behave in a way that's appropriate, and so on and so on. I don't think we could live without consciousness, and I don't think that when you put that sort of thought experiment, like the zombie experiment, or the zombie concept to people, they don't really deep down believe that it's possible.
Well, okay, so let's move to that question. So the basic question is, can you imagine making a machine, a silicon-based machine with wire and stuff, no nasty, sloppy biological material, no evolution that made it, and you design it so that it can do things that human beings do. It can play chess, it can play Go, it can make decisions and even move around. It can run a robot or something. Can you imagine that you could reach the goal of human-level performance in all of those things without it necessarily having consciousness?
I think that's absurd, because you can train the decimal point machine to beat somebody at Go, but the machine would never have invented the game Go. So it's kind of a false. I mean, it doesn't mean anything to me. I don't really see it. And the problem with machines, as much as now they realize, if you take the perfect machine, cold, calculating decisions, etc., and you remove empathy and theory of mind, you really have the personality profile of a sociopath. That's what you're left with the perfect robot.
Sociopathic robots.
A sociopathic robot running wild.
To me, yes. What do you think, Annika?
I'm not particularly worried, I have to say. I have a colleague in robotics who usually says that when people worry about robots taking over the world, they should just watch one of those games where robots play football with one another, and they realize that we're a really long way from that. I mean, you can train them to be really good at one thing and maybe some things, but I mean the complete profile of human performance.
Yeah.
You should never say never, but I seriously doubt that we will ever get there.
I think that's a risky statement given the progress in artificial intelligence, even in the last 10 years. I mean, it's absolutely true that the founders of AI in the 1950s were very optimistic about the likely speed of progress and what was going to be achieved, John McCarthy and so on. We're going to have human-level intelligence within a few years. Well, I mean, by some criteria, they did. They could have programs that could play chess reasonably well, or could solve mathematical theorems and do proofs and things reasonably well. But what that led to was, as I understand it, as soon as they tried to move computer architecture into robotics and make machines that could really operate in the world, then they realized that the big challenges are the things that feel easy for us.
Sure.
things like, you know, seeing, recognizing things, recognizing faces, or walking.
Or playing football.
You know,
Not that that's easy.
Or playing football. Those turned out to be much more difficult, but they're making huge progress.
Mm.
I mean, you look at one of the classic challenges in robotics is ball catching.
Mm.
And I saw a video the other day of a ball catching robot that kind of stood there, and balls are being thrown at a rapid rate from unpredictable directions, and this thing was going zap, zap, catching every ball perfectly.
And what else?
That's fine. So you think, you know, we need this person on the English cricket team really badly. But then the guy who was giving the talk, who's the head of robotics in Edinburgh, said, yeah, but you know, with a machine, once you can do this, you're not limited to one hand. You can use the same sensory information to control another hand. So I then showed the next bit of video where this machine was catching balls with both hands from any direction. And that suddenly became spooky. Mm-hmm. It transformed, you know, what the machine was doing to something that you could not imagine any human being doing. Well, that made me worried that if we're moving at that pace, then if you apply that same argument to every other function, solving problems, making decisions, or whatever, then when are robots, when's computer architecture going to cross that threshold of doing things which are inconceivable for human beings?
Sure, but what else could that robot do apart from catching balls?
It only did that.
Yeah.
You know, you have to understand the scale of the problem. You have to recognize the size of the computing machine we have in our head, which is, you know, so much bigger in terms of connectivity than any man-made machine at the moment. But you know, it's only a matter of time, in my view.
I know, but I'm going to disagree because you say they made tremendous progress. You just described what a lizard can do, catching flies. I don't really see how that relates to human beings. That's somewhere at the level of about a 14-month-old who's reaching for the food on the plate. Now, I'll give him that, but I just don't buy it. Until perhaps when the people in this room, and young people, older people working in the field, understand more about brain physiology and information transfer, maybe they'll get a little smarter. But I think there's a lot of hype. You know, you can do pattern identification. You can figure out that you like to buy blanks because you've went on the web 15 times and downloaded something. I don't see that as any advance in terms of understanding human cognition.
Okay, Germund.
To date, computers and robots can only think what we ask them to think, or what we want them to think, and they solve problems that we want them to solve, and so on. But characteristic of human beings is that they solve problems that they want to have solved. They have an internal motivation, and I can see absolutely no argument or no reason in principle why you couldn't give a robot those properties and give it an internal motivation, give it emotions and so on. So far, I mean, this lies very, very far into the future, but in principle it should be possible. But we tend to forget that when you talked about mathematical theorems and so on, but a mathematician who does that has a particular reason, and it's not the reason that the computer programmers have. The mathematician will do that maybe to impress a possible girlfriend, or to get ahead in the department, and there will be all sorts of motivations that you would have to give to the computer or to the robot in order to make it human. And the different, I mean, human beings are motivated by things like procreating, finding mates, and so on, procreating, producing children, and those sort of the long-term motives of most humans. And you wouldn't have a robot behave as a human unless it had those kinds of motivations. And then you're sort of very, very far into future technology to have robots, let's say, mating and producing offspring and stuff like that.
I think you're moving towards the question of things like motivation, emotions. I mean, we all feel that our lives are colored by these experiences that we call emotion: fear, hate, dread, love, pain, pleasure, or whatever. And they're important to us. We'll avoid fear, we'll seek love and pleasure. But what do they mean in terms of brain function? What does it mean to talk in terms of having this instrument in our heads which is running us as animals? Oh, and by the way, it's likely to fall in love sometime, or to be afraid of another machine. Like, what does it mean? What do emotions mean, Bob, in terms of mechanism?
Well, I think we have some idea about some of the core neurobiological infrastructure for emotional processing, and I think we know. Obviously, people know the circuitry, but the limbic circuitry we've known for many, many years. How it's the key thing is, number one, emotions are not a snapshot. They usually evolve over time, so that's important. That they're not like the presentation of a picture. They're usually something that evolves with the temporal sequence. And they can powerfully influence your, quote, conscious decision making. We know that for sure. So I think, to me, again, if you're not able to perceive your own emotion or the emotions in other people, you have a very serious problem. And I think that is a major, if you will, bottleneck in robotics. It's hard to I think it's easy. I shouldn't say easy. I couldn't do it. Relatively easy to program somebody to beat somebody at Go or chess. I think, given how little we really know about the neurobiology of emotion, I don't see how you put it in a computer code.
Annika?
I'm not quite sure what you want to ask.
Emotions, how do you imagine we'll explain them in neurobiological terms? And are they important? Are they as important as we feel them to be?
I think they're probably more important, actually. I mean, if you talk about it broadly, I think values that you ascribe to things it's basically what steers all behavior, as I understand it. I mean, and at least in my field, in decision making, I think that we have much better understanding of most aspects of decision making than we have of values, and they're probably the most important part of it. So I can tell you things that you do when you choose between two objects, and I can tell you that, pick the glass that you like the most, but where those values come from and how they actually function is something that I think that we know very little about.
Yeah, and how they're represented in the brain, how are values.
Well, I'm not a brain scientist, so I don't have to answer that question. But
you've expressed optimism about the possibility of providing explanations for behavior, except the things that don't really matter.
Exactly. Well, hopefully. I would imagine that it wouldn't be only in the brain. Probably the rest of the body would be equally important for lots of emotions.
So that leads to an important question. Yeah, it'll be in the brain. Maybe there are features of the body and having a body that are important. Let's get clear. Is there anything else except a brain and a body? If you think about how to explain what a person is, how their mind works, how they make decisions, operate in the world, is there anything more than brains in bodies? Is there anything more than molecules?
What would you suggest?
No, I'm asking you for your suggestions.
Where is it? Up in that light? Or I'm still going to say everything's between your ears. And I'll make it even, if you give me a choice of picking any born baby tomorrow on the planet Earth, as opposed to all the Google deep neural learning experts, and see in 30 years who's made a bigger contribution to humankind, I'll pick a random baby over all the fancy neural nets. And they're great. We use them for data analysis. They're all fine and dandy.
Okay. Yes, you have other views on this. I mean, let's get it on the table. What we're talking about is dualism in a way. Do we have the concepts right? And I suppose many people would have said, you raised the question of life. And even in the 1950s, still people were writing scientific publications in Nature that talked about some kind of life force, something additional from the molecules and the stuff you could observe. Is there something additional to the neurons and the connections and the synapses and the anatomy and the structure and the impulses, all the physical things that we know happen inside the head. Is there anything else?
I don't think so. But I don't think it's all in the brain. I think it's the whole body, actually. A lot of what the concepts of emotions are a total disaster, and we are totally confused about what they are. But if to take an example, is there a particular feeling of being in love? Or is the idea that you are in love, is that sort of a construction from observation of your own behavior? What you're constantly trying to do, or the person you're constantly thinking about, etc., etc. That's an inference from observations of behavior. It could also be influenced by perceptions of what goes on in your body. So if you have, when you're anxious, for instance, things happen in your bloodstream and in your blood vessels in your lungs and so on. And part of what you think about as emotions are actually perceptions, internal perceptions of what goes on in your body. So I think that you have to add to the brain observations of your behavior and observations of or interoceptions of what goes on in your body as well. But there's no sort of mysterious non-material plasm floating around.
Yeah, Annika, you agree?
Probably, but I would like to add that, I mean, when you talk about it, it sounds like there's a brain and a body, but I mean, there are loads of things around us. I mean, lots of other people with brains and bodies and cats and guinea pigs and trees and what have you. And all those things also matter, of course, for what we do and how we act and behave. So it might be a bit simplistic to just, I know you don't mean it like that, but to say, when you say it's all between the ears, it sounds like the things around you don't matter. I know it's not, that's not what you mean it, but obviously the surroundings are just as important.
Yeah, yeah.
So I would like to maybe, I'm not quite sure about the interoception part of emotion, because I know people, there's a somatic marker, your emotions are determined by your gut feeling. The problem is if you take unfortunate patients who've had complete spinal cord transections, who are quadriplegic at a C5 level, they seem to have the complete spectrum of emotions, yet they don't perceive, at least consciously, any body input. So there's I'll leave that aside by now, but I'm not sure that I think the body thing reinforces.
I've seen contradicting reports on that particular issue you raise here. I'm not sure exactly what's true here because it was a long time since I read it, but people who have damage to their spinal cord, if it's high enough, so for instance vagal nerve input is lost, their emotions are different.
Well, I don't agree, but that's
Okay.
the subject of, we can leave that aside. I think the body reinforces what your mind thinks is the emotion. That would be my view, but I think it's maybe.
I mean, there's a very interesting issue. You'll know that over the past few years there have been these remarkable observations on people with what's called locked-in syndrome, where they appear to be in a sort of vegetative state. They have a relatively intact nervous system. Their cortex is still functional, but they don't respond to anything. They can't even move their eyes. But very clever techniques have been developed to communicate with them using functional brain imaging, asking them to think about certain things, like, say, playing tennis, or thinking about walking around their own house or something. And the observation is that in some of these people, at least, who appear otherwise to be totally unconscious and disconnected, they can obey those instructions in the sense that their brain goes into the same pattern of activity that a normal person would if they were thinking about playing tennis, walking around the house. And now the clever trick is to use those two brain responses to allow the person to answer questions. So you can say, is your father's name Fred? Think about playing tennis. If the answer is yes, think about walking around your house if the answer is no, and people can give the responses. So you can then, and this is ethically quite a difficult step in these experiments, you can then start to ask people about their experience in this state. And the most remarkable observation is that when you ask people, are you happy? Are you content? They say yes. So they have no interaction with the world around them. They have no bodily sensation in the normal sense, certainly not an opportunity to interact with their body. They're totally immobile. And yet they have this sort of sense of calmness, apparently.
Can we
what do you think?
Can we disagree with the moderator?
What, you're disagreeing with the data? I didn't do the experiment.
Well, I know that first, locked-in syndrome is a brainstem state. That's a brainstem infarct. Person's fully conscious. So you're talking about minimally conscious state, which is someone who's had a cardiac arrest and they're not quite vegetative. And I know that literature, and I think it is. I'm not convinced by it. I've looked at the data, I've looked at the papers, I've talked to the researchers. I think it's got a lot of pizzazz and not as much substance. That's my read on it. I think the tennis paper with the 5 patients and 3 could respond. Actually, one of them turned out not to one of them actually had a brainstem lesion and wasn't really minimally conscious. So I want to see a little bit more proof. And the reason I say that is when you have so many unfortunate people who've had severe neurological problems and they're in this minimally conscious state or this vegetative state, unless you're really sure about that data that you're saying there, the family members hear, my God, my kid is fully sentient and I'm not doing the right thing for them. And I don't think it's true in 99% of the patients. There may be a small percentage that can perform, and people slowly do emerge from some of these states. But I think you're overstating a little bit just how happy and gleeful people are who've had a cardiac arrest and are in a hospital bed and have to have all their bodily functions taken care of by somebody else. So,
okay.
But that's speaking as a neurologist, not as a neuroscientist.
Okay. Can I turn to if we agree that neuroscientists have something to contribute to understanding how people work, if not the mind works, because we can't agree on what a mind is, then what's the best way to set about that task? Here's the objective of neuroscience. Neuroscience is going to explain human behavior, cognition, action, decision-making, and so on. What's the best way to approach that? Do we have the tools to do it? Annika. What experimental tools do you use in your work? Do you use scanning at all?
I don't use any scanning. I've used eye tracking. I think that's probably the closest I would get, but that's completely external, so to speak. Yeah.
So you measure how people behave in experimental situations where they have to make decisions.
Right, right. I think, well, I can say one thing. It's probably not what you're asking me about, but I can say it anyway. I think that one thing that we need to worry about is the type of experiments and situations that we put people into. I think a lot of research, and for some cases it's by necessity, and in some cases it's sheer laziness. We simplify the situation a lot in order to gain control. And so, for instance, in my field, when you look at decision making, you'll have lots of people choosing between, say, these 2 glasses of water, saying which one they prefer. But most of the decision making that's going on in the real world looks very different. You have many more options. They are not as similar, so there'll be lots of dissimilarities between them. Things will be chaotic and change over time, and so on and so forth. So the things that we learn about decision making when we look at people in these sort of simplified situations, that might be really important and interesting, but the question is how that actually generalizes to when you move outside of the laboratory. And as I said, I'm not a neuroscientist, but just technique as it is, I guess, would constrain a lot of the research that's going on here to quite simplified settings, simply because, if you're going to measure things, you need to keep people stable and so on and so forth. So a question I would ask, and a guess that I would have, is that it will be more and more important in the future to also try to make things more complex and sort of dynamic around the people that we study.
More realistic of the real world.
Yeah.
Okay. Well, let's park that for a second and get back to it in the context of the studies that have been done on free will. Just to continue the earlier question, do you think that the techniques are up to the job? The techniques that that neuroscientists have, all these amazing brain scanning methods and the connectomics and the optogenetics and the amazing imaging techniques and the molecular methods, is that good enough?
Well, I think the answer is no. And the reason I say it's no is because it's an evolving process. Like, I'll just do my history. When I started my neurology residency, they didn't have CT scanning.
Yes.
Right? And then, oh God, then they got MR scanning in the 80s. And then we have this front row of people with, leaders in developing methods. We keep getting more tools. And if you apply them to carefully constructed experiments, we'll continue to make progress. But having watched these things evolve, I don't know what's next. I mean, there's something may appear in 2 years that makes optogenetics look old hat, right? You don't really know. So I'm very hopeful. I mean, for me personally, from my own philosophical point of view, I'm pretty happy with who I am, but boy, it wouldn't be bad to be a 30-year-old scientist starting now with all these tools available. But wherever you start, you will know that there will be new things that will come along that you'll be very excited about implementing.
Yeah. Germund, do you agree?
Well, yes, I'm very optimistic. I think that most of the problems we've been discussing are soluble and will be solved within sort of the foreseeable future. And the techniques that are available now are extremely powerful, and they haven't been exhausted, far from it. So, of course, there are advantages of the new techniques that come out all the time, but there are still lots of important things to be discovered with old techniques. I've been amazed recently I've had reason to go back to behavior literature, behavior experiments where you have rats and rabbits running around in mazes and stuff like that, and choice situations and so on. And you find that even the sort of very, very simple experiments that people were doing almost 100 years ago, there are still very, very important questions to ask. There are still novel experiments to do that are very important with these very old techniques. It's really amazing, it's really surprising. You would have thought that people doing eye blink conditioning, training rabbits to blink in response to a tone, that after a few decades you would have sort of done all the experiments that were worthwhile. But it turns out that there are still many experiments you need to do with those rabbits.
I think you're illustrating an important point, which we did discuss earlier when we were having dinner together, that we've learned a lot about certain particular kinds of questions that you can ask in a laboratory. But on the assumption that learning about those simplified situations is relevant to the real world. But for instance, we were talking about vision. Most of what we know about how vision works, and we know a lot, we think we know an enormous amount about how the brain does vision. Most of it's been gained in experiments in which people or animals stare fixedly at one point while lights are flashed or moved around in front of them. That isn't like life. In life, we're moving our eyes constantly in a very rich visual scene. And it turns out now that people can start to look at those questions. It doesn't that knowledge doesn't transfer completely to the real world. So, what do we know about learning and memory? We know a lot about rats and mice running around in mazes and dogs doing conditioning experiments. What do we know about, emotion or about reward? We know about very constrained laboratory situations in which animals do tasks. Are you confident that those very simplified situations will tell us about the real world, about how animals and human beings really operate in the world? Bob.
You mean the fixed, like the static head fix?
Yes, exactly.
I mean, I think it certainly gives you some insights into fundamental mechanisms, but naturalistic behavior is a much more powerful drive to the nervous system. So I don't think you're going to see a one-to-one. It's just not going to be more of the same. I think new things emerge, and the system functions differently in the naturalistic environment. I would like to say that all these discussions about all this various research and how we're doing these things, people should also keep in mind is that the explosion of neuroscience research has had a really profound effect on treatment of patients with a variety of neurological and psychiatric conditions, and we shouldn't lose track of that. We should be monitoring what we do in our labs, not that our lab has to do something specifically that's translational, but as we discussed at dinner, understanding the Parkinson circuit. Now, I think you mentioned 60,000 patients at least have gotten electrodes into a small brain area that improves their movement with Parkinson's. And that all came from years of tough, basic science research from many labs. Neural mechanisms of addiction are starting to become more tractable. And there's even people trying to view addiction and rumination and depression kind of system states that could be akin to Parkinson's. And you might see brain stimulation for depression. It sounds horrible, right? Oh my God, lobotomies, but not really. I mean, it's a little, you would never think twice about not having a loved one getting an electrode put in with severe Parkinson's disease if they move better. Yeah. So I think we should be happy as neuroscientists that we have we've made a lot of progress. We have massive amounts of things to learn, but it has resulted in real effects for human beings.
I think that's a very good point, because as scientists, involved in the lab, what drives us is just the excitement of discovery. Isn't that wonderful? You've made this observation or that observation. But, I suppose the ultimate measure of success is being able to influence the lives of ordinary people. It is a measure of our level of understanding of the problem that we can intervene in disease and help people.
Right.
Yeah. Okay, finally. Free will, little tiny question. We touched on it, Annika. But no, I think one thing that many people would value a great deal and would think is, primary property of themselves, of this thing that they imagine sits inside them, this agent, which is operating them, seeing the world, making choices, doing things. Prime characteristic of that is what they would call freedom of will, and it's captured in the law. The notice of the concept of mens rea, of a stable mind capable of making judgments, being responsible for their judgments, even legally responsible for their judgments. Well, a lot of what we know about, to the extent that we know anything about it, a lot of what we know about that is from very reduced experimental situations in which people are asked just to press a button when they want to press a button or something. And the results of those experiments, as you well know, suggests that the brain is making the decisions before the person is aware that they've made the decision. And a lot's been made of that. Many people have leapt on that and said, this proves that free will is a complete illusion, and by extrapolation, that the mind is unimportant, that we really are just machines working away, and the mind is a kind of, cosmetic decoration on the top of that process. So what do you think about free will? Annika, you opened the question, Annika.
Am I for or against it?
Well,
I am not so sure about free will. It's probably kind of hard to just throw away the concept. Be difficult to run our society without it.
Yeah.
But whether we actually have it, I'm not so sure, actually.
Well, we feel that we have it.
Yeah.
Do we have it, and does it matter? That's the question.
What would it change? I mean, we behave the way we do, right? I mean, we do the things we do. We make the decisions we do. What practical?
Well, you work on decision making. So
right.
Someone's in a complex situation. Am I going to marry that person or not?
Oh,
we've been going out for ages,
right.
and you can make the list like Darwin did.
Yeah.
The pros and cons of getting married. Maybe some people do that in their heads, and ultimately you come up with a decision. That in that case, is the decision any more than making the list?
Absolutely.
Well, then what more?
I'm not sure. I'm not quite sure that the list has so much to do with the decision. I think the decision has a lot to do with assigning values to things, or figuring out what it is that you're looking for, or something like that. I mean, in the decision literature, it's often described as people looking at pros and cons for different things. But I have to say that so far I haven't seen very much good evidence that that's actually what people do. Yeah.
Bob, what do you think? Free will.
I think we have intermittent free will. I think we cycle through periods where we put things together and make a conscious, clear decision that we call free will. But most of the time we're on free form. You're in your internal world. You're thinking not about the outside world, your internal world. You're being influenced by things you don't even know you were being influenced by. You walk down the street on your iPhone and you walk past a store that's selling, I guess, Sweden, snowmobiles. And you didn't see the snowmobile, you didn't notice it, but you get home and you go on the website and pull up snowmobiles. So is that free will? I guess it is, in the sense that you pulled up the snowmobile website, but you didn't get there because of free will. Mm-hmm. So I think we're a little bit more, I don't know if oscillatory is the right word. We're more...
improvising.
Yeah, we're kind of improvising, yeah.
I think free will is a useless concept. I think a lot of what worries people when they hear about all the stuff that's going on in the brain is that events in the brain might sort of make them or force them to do things they wouldn't really want to do. Like sort of, now I want a hamburger rather than a hot dog, but suppose my brain decides before to take the hot dog instead. I think that's what worries a lot of people. I also think there's... But the brain it's designed to maximize utility, for instance, and I don't think that's sort of a real danger. There's another worry here, and that has to do with responsibility. That people say that he wasn't really responsible; he did something awful, but it was just because he had a sort of an extremely excitable amygdala or something in his brain, and that's what made him do it. But you don't really need to... Actually, I think that determinism, the idea that behavior, actions are determined by the brain, is a prerequisite rather than an obstacle to responsibility. If people were to behave sort of for completely random reasons, then it would really be meaningless to, let's say, to punish someone for behavior that we don't like. It's just when people respond to incentives that it's meaningful to punish them. So people try to control each other by rewarding good behavior and punishing bad behavior, and it's because of the lawfulness of our behavior that is a meaningful thing to do.
Mm. Mm. So you're saying, I mean, what you're saying is that decisions in the real world can be extremely rich and complex, but you can account for how people make their decisions without having to have this additional strange variable of freedom.
Yes.
People are making their decisions on the basis of a lot of factors which are weighted differently by different people. Right. So people make individual decisions, but are they really free? That's interesting.
I think it's a meaningless question.
I think
you're not free if someone is holding a gun to your head, and you're not free if you have some sort of biochemical anomaly that makes you sort of unable to follow your inclinations and to do sort of a reasonable calculation of utilities for different courses of action.
Well, you know, the time has moved on so quickly. I can hear the bells of Lund University telling us that it's 9 o'clock, which is when we're supposed to end. So I'd like to say thank you very much for joining us at Debate at Lund. Remember, this is a celebration of the 350th anniversary of this great university. I suspect this discussion will continue for quite some time, and not just here in this room. We've had some very interesting commentary on this, but this is a never-ending question. Well, maybe one day it will end, but not tonight. Thank you very much.